Okay, so when we were describing distributions, a lot of people were asking me, well, how do we find the center? And believe it or not, you already know the answer to this, which is there's numerical ways that we're going to use to find the center, and you've had experience with them. And those two are the mean and the median. We're saving standard deviation until tomorrow, but we're going to do interquartile range tonight as well. So we're going to get all of that together and define all of these things and how to calculate. Tomorrow night we'll also be learning how to numerically identify outliers and learn a more detailed way to create a box plot. And we're going to learn how to do all this with tech. So the first thing we need to understand the difference of, and this is going to be a big deal moving forward, is the difference between a parameter and a statistic. A parameter is a fixed value about the population. So if we say the average SAT score in the country, we didn't take a random sample of that. We measured every single person in the country, and then we averaged their scores together. On the other hand, if we say the average fish size in Lake Michigan, it's clearly a statistic. We caught some fish and we estimated the average fish size. We did not drain Lake Michigan and count up all the fish. We couldn't do that. And so a parameter is when we have and calculate the measurement from every single person in the population or every single test item or data point in the population. A statistic is when we take a sample, and so statistics estimate parameters. So there are three main measures of central tendency, and I'm going to go through this pretty quick because you've seen these since like 6th grade. Mean, median, and mode. The median is, we'll do first, it's the middle of the data. It's the 50th percentile, and this is a big deal, the 50th percentile. So all you do is you put the observations in the middle, and you circle the middle number if they're odd. If they're even, you find the two middle numbers, and then you find the average. Before we get into this, we're going to need to use some Greek letters and numbers. This is the Greek alphabet. Alpha, beta, gamma, delta, epsilon, so forth and so on. And the ones that we're going to use a lot in this class is mu, alpha. We use beta a little bit. But when we see these things, don't freak out. They're just Greek letters. They're being used in addition to things that we're already doing, lambda, pi. We'll see a bunch of these. Delta. You've seen this one for a while, pi. So to find the mean is the arithmetic average. And so I'm going to give you a formula for mean, and it's going to freak you out. It's right here. So the mean is the sum of all the values, and there actually should be an I there, divided by the number in the set. So n always is the number of data points. Right? N is always the number of data points. So all this is saying is add up all the data points and then divide by the number of observations that there are. So the big difference is we're going to use different letters. If we are talking about a parameter, if we're talking about we're representing the entire population, we'll use mu. If we are talking about a sample, we'll use this symbol, which you call X bar. But this is, we know how to find average. Mode is the observation that occurs the most often. There can be more than one mode. If all the values occur once, there is no mode. And it's not used as often as median. So we have two measures of central tendency. So which are we going to use? And the basic rule of thumb is in a symmetrical distribution, the mean and the median are the same. In a skewed distribution, the mean is pulled in the direction of the skewness. So if it's right skewed, the mean will be pulled to the right, away from the median. If it's left skewed, the mean will be pulled to the left, away from the median. In a symmetrical distribution, you should report the mean. In a skewed distribution, especially if it's strongly skewed, the median should be recorded as the measure of center. So, measures of spread. Measures of spread. So, we use range, but range is kind of useless. Range is just the maximum value point minus the minimum value point. Now, you've done this before, but they've generally been given to you. So how do you find the first and third quartiles? How do we figure out where those occur? Well, the first quartile, or the 25th percentile, I'm sorry, there shouldn't be this decimal here, is going to be halfway between the minimum and the median, and the third quartile, which is the 75th percentile, will be halfway between the maximum and the median. And don't worry, we're about to do this with a data set, so don't freak out. So the interquartile range is the distance between Q3 and Q1. And so we're just going to subtract that, and that'll give us an actual numeric value that describes the range. And if we have some really big number or some really small number in the data set, it won't be affected because we're not going from the ends of the data set, we're going from the 25th to the 75th percentile. So the IQR will be the middle 50th percentile. Will be a numeric representation of the middle 50th percent. So here we have a data set. This is the weights of the men's 2008 Olympic men's rowing team. This is the picture of the men and the women on the rowing team. And here are their weights, right? So how do we find the median, the first quartile, and the third quartile? And it's not a symmetrical distribution, I'll tell you that now. If you wanted to, you could do a histogram of it, but you would see it's not. It's bimodal with skewness. So here are all the data points. So there are 25 data points, n equals 25. So if we go in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There is the median. There's 12 points above, and there's 12 points below. So to find the first quartile, we do the same thing. So now there are 12 data points here. So we go in 1, 2, 3, 4, 5, 6, 7. And then there's 1, 2, 3, 4, 5. So we have to average those 2 points, and that will be the first quartile. So 181 plus 194 divided by 2. Right, so we go 181 plus 194. And we get 187.5. So this is quartile 1. The median we said was 205. And so we do the same thing. 1, 2. So we're going to average those, and we'll get 217. I can do that one in my head. So Q3 is 217. So lastly, it asks me to find the IQR. So the IQR is Q3 minus Q1. So that's going to be 217 minus 187.5. By the way, I've been doing something wrong. All of these should have units. In stats, units have to go on everything. Sorry. So the IQR is 29.5 pounds. So about 30 pounds difference encapsulates half of the group. Now, look at this value. In rowing, there's this person called a coxswain. And the coxswain sits in the back of the boat. They don't actually pull on any oars. They just sit there in the 8, in this case, in the Olympic squad, and they steer the boat. So the question here is this an outlier? I mean, look at all the other values, 200, 194. There's a few 1 values in here. That's the men's lightweight 4. But this point's way out there. And so here is our first definition of if something's an outlier. If it's more than 1.5 times the IQR above Q3 or Q1. So we had, if we go back, we had Q1 was 187.5. Q3 was 217. And the IQR we said was 29.5. So